Yeah, I mean, I'll give one concrete example. So he really wanted to be able to read manga. This is something that I mean,
Yeah.
it sounds like a simple thing, but it's actually a really big deal for him. And he couldn't do it with this mouse stick. It wasn't accessible. You can't scroll with the mouse stick on his iPad on the website that he wanted to be able to use to read the newest manga. And so
Might be a good quick pause to say the mouth stick is the thing he's using, holding a stick in his mouth to scroll on a tablet.
right, yeah, it's basically you can imagine it's a stylus that you hold between your teeth.
Yeah.
It's basically a very long stylus.
And it's exhausting, it hurts, and it's inefficient.
Yeah, and maybe it's also worth calling out there are other alternative assistive technologies, but the particular situation Nolan's in, and this is not uncommon, and I think it's also not well understood by folks, is that he's relatively spastic, so he'll have muscle spasms from time to time, and so any assistive technology that requires him to be positioned directly in front of a camera, for example, an eye tracker, or anything that requires him to put something in his mouth, just is a no-go because he'll either be shifted out of frame when he has a spasm, or if he has something in his mouth, it'll stab him in the face, if he spasms too hard. So these kind of considerations are important when thinking about what advantages a BCI has in someone's life. If it fits ergonomically into your life in a way that you can use it independently when your caretaker's not there, wherever you want to, either in the bed or in the chair, depending on your comfort level and your desire to have pressure sores, all these factors matter a lot in how good the solution is in that user's life. So one of these very fun examples is scroll. So again, manga is something he wanted to be able to read. And there's many ways to do scroll with the BCI. You can imagine like different gestures, for example, the user could do that would move the page. But scroll is a very fascinating control surface because it's a huge thing on the screen in front of you.
Mhm.
So any sort of jitter in the model output, any sort of error in the model output causes like an earthquake on the screen. Like you really don't want to have your manga page that you're trying to read be shifted up and down a few pixels just because your scroll decoder is not completely accurate. And so this was an example where we had to figure out how to formulate the problem in a way that the errors of the system, whenever they do occur, and we'll do our best to minimize them, but whenever those errors do occur, that it doesn't interrupt the qualia, again, of the experience that the user is having. It doesn't interrupt their flow of reading their book. And so what we ended up building is this really brilliant feature. This is a teammate named Ruse who worked on this really brilliant work called QuickScroll. And QuickScroll basically looks at the screen and it identifies where on the screen are scroll bars. And it does this by deeply integrating with macOS to understand where are the scroll bars actively present on the screen using the sort of accessibility tree that's available to macOS apps. And we identified where those scroll bars are, and we provided a BCI scroll bar. And the BCI scroll bar looks similar to a normal scroll bar, but it behaves very differently in that once you sort of move over to it, your cursor sort of morphs onto it. It sort of attaches or latches onto it. And then once you push up or down in the same way that you'd use a push to control, the normal cursor, it actually moves the screen for you. So it's basically like remapping the velocity to a scroll action. And the reason that feels so natural and intuitive is that when you move over to attach to it, it feels like magnetic. So you're like sort of stuck onto it. And then it's one continuous action. You don't have to like switch your imagined movement. You sort of snap onto it and then you're good to go. You just immediately can start pulling the page down or pushing it up. And even once you get that right, there's so many little nuances of how the scroll behavior works to make it natural and intuitive. So one example is momentum. Like when you scroll a page with your fingers on the screen, you actually have some like flow. Like it doesn't just stop right when you lift your finger up. The same is true with BCI scroll. So we had to spend some time to figure out what are the right nuances when you don't feel the screen under your fingertip anymore. What is the right sort of dynamic or what's the right amount of page give, if you will, when you push it to make it flow the right amount for the user to have a natural experience reading their book. And there's a million, I could tell you like there's so many little minutiae of how exactly that scroll works that we spent probably like a month getting right to make that feel extremely natural and easy for the user to navigate.